Hello everybody. Now we are going to solve a problem from GATE 2025 EC question paper, and the question number is 19. The question is, consider a part of an electrical network as shown below. Some node voltages and the current flowing through the 3 ohm resistor are as indicated. The voltage involves at node X's. This is the question. Okay. So this network is given. Here we have some 2 ohm, 1 ohm, 3 ohm, 2 ohm again. This part of the network is available. 9 volt voltage source and 8 volt voltage source are given. Now let's start analyzing the circuit. We want to find out the voltage at this point, right? So we can name it as Vx. So the question is to find Vx. Here some more part is given, but this is actually of no use. Just to scary thing that all the details are available in this part, right? Voltage source is there, current is also available, resistor is also available. So we can apply this Ohm's law. Whenever you apply Ohm's law, V is equal to IR, right? So this voltage across this resistance can be calculated. So the current value is 1 amp multiplied by this 3 ohms resistance, then this is 3 volts. So the drop across this 3 ohm resistance is 3 volts. So initially you have this 9 volts voltage source. From that you have the drop of 3 volts. That means at this point you will be having 6 volts, right? This point is 8 volt and this point is 6 volts. So here you have these two resistances with the starting point with 8 volts and this ending point as 6 volts. And here you have 2 ohm resistance and the 1 ohm resistance. They are connected in series, right? These are series. So the same current will be flowing through this. So this current value we can take it as some Ix, right? So we can calculate again this Ix using Ohm's law, V by R. Since we have the series part, the total resistance is 3 ohm only. As we have the series part with the series resistance, they can be taken as 3 ohm, because just by summing up we'll get the equivalent resistance here. So what is this value? This is the difference, right? So 8 minus 6 divided by this 3. So it is 2 by 3 amps. So Ix is equal to 2 by 3 amps. That is equal to 2 by 3. So actually what is needed? Vx is required, right? So how much voltage drop will occur across this 2 ohm resistance? Voltage drop across this 2 ohm resistance, that can be calculated as V equal to IR. I is 2 by 3 amps multiplied by resistance 2. So it is equal to 4 by 3 volts. Now you can easily calculate this Vx. Vx is equal to initial voltage 8 volts minus the drop across this 2 by 2 ohms resistor, that is 4 by 3. So it is taking common denominator, it is 24 minus 4. That means the answer is 20 by 3. Okay, so this is the answer. Thank you. Hope you have understood.